Okay, as we're looking at parametric equations, parametric equations are really actually kind of nice for us when we want to write a system of equations that relates both a horizontal distance and a vertical distance, and a horizontal place or spot and a vertical spot at a certain time. It's called T is usually what we use for that, and it's called the parameter of the equations. And the easiest thing to do is think about, a bug crawling on the table. That bug is not going to crawl in a straight line or any kind of line that we've, dealt with. And so if you look at the picture that I've got, if we did a vertical line test or a horizontal line test, it'd fail both of those. So we can't actually write it as a function of x with respect to y or a function of y with respect to x. So we actually have to kind of write it as two separate functions with respect to t. This is used a lot in physics. It's used a lot in projectile motion for things. And we are going to keep it pretty basic for what we've got going on. Okay, ready to parametric equations in rectangular form, then sketch the curve. So here's what you really have is what you're going to have: an x equals a something with a t and a y equals a something with a t. Whenever you see the t that is parametric, to get rid of that, to make it into rectangular form, you have to get rid of the t. So for this first one, it's actually very simple. You are going to take the y equals a t, and you're actually, oops, sorry. You are going to take, let me undo that. You're going to take the y equals t, but you're basically going to take your y and plug it in right there in your x equation. So you've got x equals a negative y squared over a 6. And then I'm going to multiply both sides by a negative 6. So I get a negative 6x equals a y squared. Now, here's the thing. This is a parabola. We've done parabolas. We did parabolas first semester. And the thing is, you don't have to remember everything that I'm going to do next, because ultimately we are just going to, once we rewrite these, this is us rewriting it in rectangular form. So that part is done. Sketching the curve, we're going to do straight with a calculator. But a couple of things I want to call attention to. This is a singleton x equaled a squared y. So that means this parabola is going to either open left or right. And because our number 6 is negative, it's going to open left. Okay? And again, I'm just kind of reminding us of what parabolas look like when we first graph them. Our vertex is going to be 0, 0, because we don't have anything. It's like not x minus anything or y minus anything. Right? And remember, we took that number, whatever number was there, negative 6 equals a 4p. And then so p is actually going to be negative 6 divided by 4 is really negative 1.5 or negative 3 halves. And we use that to graph our focus. We use that to graph our directrix, everything like that. So I'm going to graph a couple of those, and then honestly, I'll call attention to what you should do in your calculator. But there's our vertex, right? Whoops, I don't know what I just did. I just highlighted the whole screen. I'm not sure what's going on. So there's our, no, I don't, oh, I must be doing something weird. There, okay, there we go. There's our vertex. Terribly drawn, but there's our vertex. And then we count to the left 1.5, and that is, keeps doing that. That is our focus. And then we count to the 1.5 backwards, and we had that vertical line, or it wasn't always vertical, it was just this case, that we call the directrix, right? Okay, and again, guys, I'm just reminding us of what it was. We will go straight to the calculator when we graph these. And then what we have to do, we had our vertex, we had our focus, oh, we had the LR. And remember, that was, we went to where the focus was, right? And we're going to count out, we basically cut this negative 6, we cut it in 2. So we're going to, well, we can do a positive 6 ultimately. We're going to count up 1, 2, 3, and count down 1, 2, 3. Woo! All right, I don't know what I'm doing. I'm doing something weird with and it keeps trying to tell me that I want to either select everything or cut everything or copy paste. I don't know. But ultimately, that's all we really needed, right? And there is our parabola. Ooh, terrible. Okay. Now, the only thing that's different with a parametric equation is that you have a starting point, you have an orientation, so you have a direction. So what I want you to do is I want you to go to your calculators. I want you to follow the instructions on that little half sheet that says instructions for graphing. So you know you're going to set up your mode so that you're in degree, that you're in parametric as far as the functions. Because this is it only has a single, like it's just got t's, there's no trig functions, you don't see a sine or a cosine or anything like that. I want you to hit your window button and I want you to set your parameters like -10, 10 for the t min and the t max. Like I screenshotted it, I put it on the instruction sheet so it's all there. And then all I need you to do then is go to your y equals. And when you go to your y equals, you'll notice now that you've got like an x1 and a y1, and an x2 and a y2, an x3 and a y3. Your x1 is going to be this equation. Oh, that highlighter's not great. That first equation, x equals -t squared over 6. Okay. Your y1 is going to be y equals t. And you just enter it, -t squared divided by 6, and a t. Okay. Now, before you hit the graph button, I want you to do one thing. I want you to make sure that you are ready to watch the calculator. Because if you watch the calculator will do a couple things for you. It'll not only graph your shape, but it will also graph your direction. You have to watch where your calculator graphs your parabola. Okay? And if you hit the graph button, what you notice is that your parabola starts basically in quadrant 3. It swings up, hits the vertex at 0, 0, and then it swings out and goes out on quadrant 2. So your direction, okay, and that's what you have to add. That's what's the new part. Your direction is this. Okay, so we're starting in quadrant 3 and heading out to quadrant 2. Now, I told you that you don't actually have to graph it the way we would have graphed it. So all I want you to do is I want you to go and hit second graph to go to your table. And you're going to have 3 columns. You've got a t column for time, you've got your x1 of t, and you've got your y1 of t. All you really need to do is find some nice numbers. So at t equals -6, you'll see that x equals -6 and y equals -6. So really, and I'll adjust it a little bit because I didn't do a very good job, you should have a point at -6, 6. So really my parabola should have gone through down here. Sorry, didn't draw that very nicely. Then you also have a -1/2, 3, which totally we have that one there. That one I did graph nicely. You've got a 0, 0. When time equals 0, you got 0, 0, right? And you're looking at the second and the third column to actually graph. And then at time equals 3, you've got a -1/2 and a 3, which again, we already graphed, right? And then if you go to time equals 6, you've got x equals -6 and y equals +6. Ooh, I was a little bit better there. Okay? So you can actually just use your graph to grab your points too.